Hello. In this video, we're going to be talking about limits as we approach infinity. Now, before we get there, I have a function here. The function is x squared minus 2 over x squared plus 2. And I have the graph sitting right here. And you can see that as we follow this out, as we follow our x's out along here, we approach a certain value for y. And as we follow out to the left, we approach a certain value for y, and it happens to be the same value in both cases. So as our values for x, as x gets huge, so as x approaches infinity, our y values are approaching the number 1. So we have this line, this dotted line here, y equals 1. We're getting super, super close to it. Now, it'll never actually get there, but it is getting close. Same if we went the other way. If x approached negative infinity, our y values are still approaching 1. So what this allows us to say is that our limit of f of x as we approach infinity is 1. And our limit of our function as we approach negative infinity is also 1. And you can see how our y values are trending toward this line. Now, the line is dotted because it's not part of the function. The line, this y equals 1, is an asymptote. That means our function is getting closer to it but never actually reaches or touches it. So even though we don't ever actually get to 1, as our x's get larger and larger and larger, or smaller and smaller and smaller, we're still trending toward the number 1. So this can lead us to a conclusion. If we have the limits of some function as the x's get huge, positively or negatively, and that limit value is equal to L, then that means that we have a horizontal asymptote at y equals L. So if I know, let's say, that the limit of f of x as x approaches infinity is 7. Well, that means on my graph that at 7, where y is 7, we'll have some horizontal asymptote that our graph will approach but never quite get to. Okay, for now we are done.